years ago, I would never have thought that I would have worked for the European Space Agency. And here I am. And 25 years ago, I would never have thought that I would have the privilege to be sitting in front of all you today, interviewing a group of experts who are working for the Ariel project, who are here today to talk about life of an ESA project. So it's really my privilege to host this session. So I just want to address, we've got people on YouTube where there's a live stream, and there's also people on ESA Web TV. So for the people on YouTube, we would encourage that you put questions into the chat. And if you do so, if you could please put your name as well as the city and country in which you're from, and we will try to get to as many questions as we can. So, so as the presentation proceeds, then please just come forward with your questions. Also online on YouTube, we have a couple of colleagues in the background who are also going to be answering some questions online. So, okay, so I think we can start. So, so I have three expert panelists today, so I'll allow them to introduce themselves. So Jean-Christophe, you would be so kind.
Yeah, thank you, Fiona. Hello everyone, my name is Jean-Christophe Salvignol. I am the Ariel project manager. I'm French, 53. I've been working for the agency for 20 years, actually, and always in the science directorate. Before Ariel, I worked on Euclid, a mission that was developed to study dark matter and dark energy. Before, I worked on James Webb, you know, this huge spacecraft that's being launched in December last year, developed by together with NASA. And before that, I worked on Rosetta. You saw a few pictures on the small movie that you had before, where you had the lander that went for the very first time on a comet.
Okay,
right.
so Salma, please.
I'm Salma Fahmy. I'm the Ariel mission payload and AIV manager. So I've been in this position for about 2 years. I've been working for ESA in total for about 20 years as well. I started as a young graduate trainee in Earth observation, and then worked for a while in ESOC, also on scientific satellites as payload operations engineer for 2 astronomy missions. And then since then I've also been payload engineer for Solar Orbiter, which was also launched in 2020, just before COVID hit, where I was responsible for 3 instruments on that satellite as well.
Okay, and Gonzalo.
I'm Gonzalo Saavedra. I'm from Spain, 14 years in ESA already. My background is a bit 2 degrees, one in astrophysics, another one in aerospace engineering, which I managed to combine in my current job. I have been young graduate trainee, part of the young graduate trainee program in the current design facility as the first step in my career. Then I was control systems engineer in different companies in Germany and Spain. And then came back to ESA as system engineer, working in the Euclid project together with Jean-Christophe for quite a number of years. And now I have the opportunity to be the spacecraft and launcher manager of the Ariel mission, and like Salma and Jean-Christophe for 2 years in the project now.
Excellent. And I have the privilege of being the human resources advisor for these colleagues, I have to say. So that's absolutely a privilege for me. So we're going to now spend a little bit of time talking about the Ariel project. However, Ariel happens to be one of the projects of many scientific projects within the agency. And maybe to turn over, I'll turn over to Jean-Christophe to talk about some of the other science missions and how Ariel fits into that. So, Jean-Christophe.
Thank you. If you can put the slide.
Yeah.
Okay, in the science directorate, we have different missions. We have many missions. Some are for exploration, like Rosetta that I've mentioned before, but others are for observation, for astronomy, pure astronomy. And we try to observe the universe in all the wavelengths that we can. Okay, and for that we have developed a family of many satellites to observe between all the wavelengths that you can see on the screen now. Among all those missions, several of them are dedicated to exoplanets, because this is really a science that is booming in the last years. the first one was Cheops. It has been followed by Plateau, and now we have Ariel. So it's this family of missions are there really to study even further the exoplanets science. Okay. So if I move to the next slide.
Well, maybe I can just
You can see?
interject here, Jean-Christophe. Ariel is about exoplanets.
Yes.
Is that correct? Can you explain to us what is an exoplanet for our viewers?
It's very simple actually. An exoplanet is just a planet, but this planet is far, far away. It's a planet that is not in our solar system, and of course there are many types of exoplanets because there are many types of planets in our own system, and we consider that probably there are even more variety, more diversity of planets that we can find even further away in the universe.
Okay. What else can you tell us about Ariel?
Ariel is, I think we can maybe move to the next slide where we can see a bit Ariel is a mission that has to answer to 3 questions. This is the question you can see on the screen, is what are exoplanets made of, how do they form, and how do they evolve? Okay. And for that we have developed a mission that I'm going to describe a bit further. Okay. This is a nice view actually from the spacecraft when Ariel will leave the Earth to go to the Lagrangian point 2 area where we'll observe, we'll make all the observations. Here, this is the spacecraft that we are developing. It basically consists of a platform that you see in yellow, on top of which a telescope is mounted. You will get a bit more details on that one. But the trick we're using is the same one as we use for all the exoplanet missions. Okay? So basically, we are looking at the point in time where the planet is going in front of its star. And there we have a variation of the light that we detect. And from that, we are able to see the size of the planet. We can deduct its mass as well, therefore the density. And this is basically all we can do nowadays with the current missions. So again, we know the mass, we know the size, and we want to know a bit more because, as I said before, there are many planets. Okay? So one big advantage of Ariel is that we are going to do a survey. We are going to observe many planets because we know they're not all the same. And for that, we are going to observe up to 1,000 planets, and then we get a good idea of the diversity. So diversity in terms of size, in terms of level of evolution. It could be early planets or late old planets. And then another big advantage of Ariel is that we are going to observe the atmosphere of the planet. Okay? We don't know much today about the planet composition. As I said before, the standard techniques mainly tell us the size, the mass, and the proximity, of course, to the planet. There, thanks to Ariel, we'll be able to observe through the atmosphere and detect all the components, the chemical components of the atmosphere. And from that, you can even deduct what is in the core of the planet. So we can know if it's ice in the planet or more rocky type of planet. So we'll get much more information on the thousands of planets that we have already identified, and that are, again, that are very far away from here.
So one of the questions a lot of people ask is, I mean, there's an awful lot of energy, time, commitment going into these projects. How long do you think, from inception to launch, how long does a project take? Does this project take?
Those projects are very long, typically, because we develop a mission for a very specific purpose. So they're really tailored for the scientific objectives. Okay. So Ariel, it started 2 years ago. Will be launched in 2029. So typically, it takes 8-9 years to develop a space mission. So indeed, it's a long journey that we have in front of us.
So in fact, it's a huge commitment in terms of the team. I mean, when you go into a mission, as a project member, I mean, it's a long-term commitment. It's not something you just switch after 2-3 years. It's something, if you want to stay until launch, then it requires quite a bit of commitment from the staff.
Indeed, it's not a job for career hopping. If you want to
Yeah.
do 2 years there and there, it's not the type of job you want to do, because it takes long, of course.
Yeah.
But it doesn't mean it gets boring, because you have a lot of different phases in the project with different challenges, different skills also that you need, and you need to develop and evolve. And I must say it's extremely enjoyable actually to start from scratch and make a spacecraft
Yeah.
out of it.
Just in the order of magnitude, Jean-Christophe, how much will Ariel cost in the end?
All right. If you see the overall ESA contribution, we speak about 560 million. So it's quite a significant budget. On top of that, we have some collaborations. We have one major collaboration with a group of institutes, scientific institutes, that deliver the payload. I think we'll come back to that later. And this is another 100 to 200 millions. And then also NASA is also a part of the project, and they collaborate for a few tens of millions. So all in all, I think we speak about around 750 millions.
Okay, so it's quite a substantial amount of money. Yeah.
Indeed. Yeah.
Yeah, okay. Now, I'm just wondering, maybe we can talk a little bit about the organization of a project team, because I can imagine that when you come into the ESA as an organization, you want to know who you're going to be working with. So in terms of organization, how did the different roles in the project work? And maybe you can do a brief introduction, and then maybe Gonzalo and Salma can speak about their specific roles.
Okay, very good. Yeah. Actually, this is the job of the project manager when he starts a job, to build up the team. I think we have a slide on that one that we can show, and it will give you an idea of the typical project organization. That will.
Yeah.
Okay, this is the one you have on the screen. So, working with the project manager, we have all. We are articulated around two big teams, actually. One for the spacecraft, managed by Gonzalo, and one for the mission and payload, managed by Salma. I will come back to you two so that you can explain a bit what you do, because it's really the two pillars of the project. Of course, we are supported by the project controller team, which is following all the non-technical activities. We are supported also by contract officers, because we have a lot of contracts with industry, and we need to manage them. We have what else? And then we have also we are in the project. We are in charge also of the ground segment. Okay. So basically, it's all the antenna on ground that are there to get the information from the satellite, distributed to the scientific community after post-processing. Okay. And for that, it's done in two parts. One team that we have at ESOC, which is an ESA center. It's in Germany. This is the center that really operates the spacecraft in flight and get the data. And then the data is sent to another center in Spain. It's ESAC. And they are processing the data, make sure it's of good quality, the scientific data, and then distribute it to the scientific community. Okay. But then I will leave the floor to Salma, who will speak about the section.
If I may, just to I think for a lot of the people that are viewing today, maybe just a brief explanation about ESA and the way it works in terms of project management, because we actually describe ourselves as a procurement agency, in fact, don't we? So we are coordinating the project, but we actually award contracts to space industry. And in the case of Ariel, we also have academic and scientific consortiums who are actually providing the payload, the instruments. So that's one important thing to mention in terms of working at ESA, is that we have a fabulous test center here at ESTEC, which is our establishment in the Netherlands. We have phenomenal technical facilities here, but the actual building of the satellite is done by our industrial partners. We actually don't build the satellites ourselves. We actually manage the building of the satellites with industry.
This is very correct.
Yeah,
yes,
yeah,
indeed.
yeah, yeah. Okay, so Salma, maybe you can briefly describe your role.
So I'm mission payload and AIV manager. So I'm responsible for, in principle, the payload. The payload is the part of the spacecraft that is actually making the scientific observations. So in the case of Ariel, it's a big telescope, which then focuses and channels the light into two separate scientific instruments. And the key thing about Ariel is, in particular, that we're going to do spectroscopy, as Jean-Christophe mentioned, which will allow us to get an idea about the composition of exoplanets. So I'm responsible for overseeing the complete payload development. The development of the payload is actually done by a collaboration of scientific institutes. So it's actually contributed to the mission. So we don't have a contract with these institutes. It's all managed through international agreements. So I oversee the work that's done by them in the design, development, testing of the payload. And then I'm also responsible for what we call the mission performance. So as Jean-Christophe said, we have various parts of the project, which is, the space segment, which is the part that actually flies the spacecraft, but also the ground segment, which takes care of the data processing. And the contributions to the overall mission performance comes from both. So I'm kind of responsible, me and my team, for overseeing kind of how all of that is split. And then also the AIV, so that stands for Assembly, Integration and Verification. So this is how all the various test models are designed, put together and tested, because one of the important things about projects like ours, because they're one-off, they kind of have to work first time. So there's a lot that goes into building test models to make sure that when we have the real flight model, it actually works. So that's a whole process as well.
I think you mentioned a very important aspect, because what your project team is building, similar to many other project teams in ESA, is, as you said, a one-off.
Mm-hmm.
So it's not an assembly line, like it is at a car manufacturer. We wish we would have a Tesla plant here, but but we're really doing everything for the first time.
Yeah.
And I think that's probably a big reason why some of these missions cost the amount that they do, is because it's not an assembly line. We're really creating brand new technology and brand new science for the first time. Good.
Yeah, absolutely.
Gonzalo, if you could say a few words about your role.
Yeah, I am in charge of the spacecraft and launcher manager. I'm the spacecraft and launcher manager. And in my group, basically, we take care of the other part of the spacecraft, the one that provides the services to the payload. The payload is the ultimate, let's say, and most important part of the spacecraft, because the one doing the science. But the service module, as we call service module sometimes, provides the power, computing capabilities, the structural, thermal environment, controls the pointing of the spacecraft. So all these disciplines are part of the design of the spacecraft and the platform. As you said, a platform in a science mission is not a recurrent product, it's a one-off. So we have a lot of new things to develop with respect to previous missions. We follow the contract with the industry, as you said as well. We are a procurement agency. We follow the design, but in the end, the design is not done by us, it's done by Airbus in this case, with a group.
By Airbus.
By Airbus.
Yeah, Airbus France, isn't it?
Airbus France,
yes,
together with Airbus Stevenage in UK. And below them, they also have a large group of subcontractors that they provide either units, subsystems, or services. And we follow all this process, so the design and procurement of all these units and subsystems. The other thing we do is to interface with the ground segment. We coordinate the interface with the ground segment with ESOC, which has...
Could you explain what a ground segment is?
Ground segment is basically ground control. It's the part on ground.
It's like mission control in a way.
Control.
Yeah.
Mission control.
Houston.
Yes. It's our Houston, but it's in Germany.
Yes.
And this interface is very important, because apart from keeping the spacecraft running and completing the mission, it has a lot of impact in the design of the spacecraft. In terms of software, computing, with the onboard computer. There are many interfaces we have to take care from the very beginning to be able to control the spacecraft from ground. And the last thing we do in my section is to coordinate the interfaces with the launcher. The launcher basically drives the structural needs of the spacecraft and many other things. So the fact that we are also launching with Ariane 6.2, which is an additional challenge because it's a newly developed launcher, and we take care of this interface as well. And we do it with a team of experts in all these disciplines who are also supported in the matrix of our organization of ESA, of all different disciplines involved in the design of the platform.
And there's also a very unusual aspect of the Ariel launch, isn't it? Isn't it a co-passenger?
Yes.
It's a co-passenger
Yes.
with one of our ESA missions. Maybe you could just say a few words about that?
Yes. In order to take a benefit of the capability of Ariane 6.2, which to the Lagrange 2 point as a capability of more than 2 tons, almost 3 tons of mass to be launched, and being Ariel a spacecraft of less than 1.5 tons, ESA has taken the benefit to put another spacecraft, which is Comet Interceptor. And the way it's launched is we have Ariel is in the bottom position of the launcher. It's covered by a structure that's called a dual launch structure, and Comet I goes on top. And the way it happens is that once it's launched, first we release the Comet I, and then after we do Ariel. So it's an interesting dual launch. It was done in the past as well in science with Herschel Planck, and in different other parts of ESA as well, when they have a co-passenger for programmatic reasons, it's also done in other programs.
Yeah, so this is an interesting aspect, actually, because we've got the Comet Interceptor project, which is running in parallel, done by some other colleagues within the Science Directorate, and I can imagine that you have to work very closely with them, working towards that ultimate goal of launching on the same day, on the same launcher, at the same time. And I can imagine that brings up lots of different challenges as well.
Yes.
Yeah.
That's part of the fun.
That's part of the fun. Excellent. Okay. Very good. And the launch is scheduled for 2029, correct?
Yes.
Okay, 2029. So watch this space. All right, so that's a little bit more about the work that you do. But in terms of building up a project team, so I also had the privilege of supporting Jean-Christophe in building up his team. And so how big is the team, Jean-Christophe?
Well, okay, directly under in the project team, we have 12
people, yeah.
people.
Yeah.
And I was hesitating a bit because actually sometimes we have also a matrix structure. We get the people from that are not directly reporting to the project manager, but de facto, like the project scientist, the contract officer, they're almost part of the team, actually. We are working very, very closely with them.
Yeah, yeah. And I think this is a really important aspect to mention, too, because the core team is 12, but you have the team in mission control. You also have the team in ESOC, in science operations. You mentioned the project scientist. And of course, prior to that, Ariel was in what we call the study phase, which is a feasibility stage as well. So it's a very, all these projects are extremely complex and require lots and lots of manpower from different sources, but it's good to know that the core is 12. And in fact, you and I started together, didn't we? I mean, you were appointed as project manager, and then we slowly but surely built the team, and Salma and Gonzalo were the first 2 hires. Mm-hmm. So in your opinion, what is the biggest challenge in terms of building a team, both in terms of technical competence, but also in terms of team dynamics, personality?
Okay. Okay. First, you have always some budgetary limitations. You cannot employ 100 persons because it's better like that. Okay. And then you have other constraints. So you have to also reuse people from other projects. Okay. So and then you have your network of people. People have been working with in other projects or from the technical directorate as well. So there's a pool of people that you can use actually to build up your team. Then of course you have to think what is your big challenge, why, and then you have to build up your team in such a way that you're reactive and efficient against those challenges. For us, one of the biggest challenges is the payload. That's why we have put quite some effort by recruiting Salma and then a good team below. Then we had also the spacecraft is always a big contract, so also it requires its own team. with different competencies. People that are more used to manage big contracts. What else can I say? And then on the team spirit, this I must say up to the project manager first, and then to the rest of the managers to put some kind of spirit, and that's something you can see through the interviews, where I got your support to really detect the spirit you want to put in your team.
Yeah.
Like, do you want to work in a cooperative way or not? I mean, that's something important.
Maybe I can just interject here and ask Salma a question, because Salma, when you were explaining your role, you mentioned that you deal with what are called the academic and scientific consortiums, where you don't necessarily have a contract with them.
Yeah.
So whereas Gonzalo has an industrial contract, and there's money in question, the people that work in your team have to use different influences in order to achieve their goals. Can you maybe say something about that?
Absolutely. So, it brings challenges, but also benefits, because at the end of the day, everyone's working for the same goal. And ultimately, as I think you also said, Gonzalo, the payload is the final customer of the mission. So everyone who's working for the scientific institutes that are building the payload actually have, they're the ones that it's their baby, if you like. It's their mission. They're the ones that will be using the data at the end. So from that point of view, there's no need per se to kind of coerce anyone to kind of get the best out of the mission. The biggest challenge really lies in the extent of the different parties that are involved in the payload, because there's really contributions from institutes all over Europe, each doing little pieces. And so it's more a case of making sure that the systems are set up in a way that information flows between the different parties efficiently, that everyone's on the same page, that the communication works. And also to manage the different funding cycles, because the funding comes from national agencies, and the systems are different in each of the countries. So there's that element of it as well.
I think that's an important point, because what a lot of people they compare ESA to NASA, but NASA is one country, and the Indian Space Agency is one country. We have a particular challenge at ESA where we have 22 member states that are all contributing towards our space programs, and of course 22 different inputs in terms of what their priorities are, etc. And in your situation with the scientific institutes, how many institutes are you working with?
I think there's about 20.
About 20.
That order of magnitude. Yeah.
So it's quite a challenge then to juggle the interests of 20 different institutions. I can imagine it's quite. So would persuasion and be a strong aspect of the personality of the people in your team?
Oh, for the people in my team, actually, it's I would say problem solving.
Problem solving.
Yeah.
Okay.
So positive attitude and ability to kind of approach problems in a constructive way, and to find maybe alternative ways of looking at things. Yeah, and a high level of organization and communication skills, because communication is such a key part of it. Also in terms of kind of making sure that the communication between the institutes is working.
Yeah. Okay.
Yeah.
So Gonzalo, you have in the past you've worked in the study phase. In fact, you worked in the development phase, then you went to studies, and then you came back. So what is it specifically? What is your favorite part of working in a project in ESA?
Yeah, in ESA it's very important, because you look at a project or an endeavor from the top of the pyramid. You have to deal with all the stakeholders, scientists, industry, ESA. That is very interesting. It's very challenging, but it's very interesting. Working in a project compared to maybe other works in which you are an expert in a discipline, you need to have a system view, you need to have a transversal view, which is something that allows you to learn a lot. And on top, you work with a team of people And it's not so much about how you know when you work in a project, it's about how much you learn from the other members of the team. And you learn every day. You learn from industry, you learn from your colleagues, and that is very exciting. You are exposed, you're quite exposed, but it's really rewarding.
Yeah, and that's very true, because a lot of people, when they're applying to ESA, don't realize what incredible support structure there actually is in the agency.
Mm-hmm.
I mean, the agency is filled with experts from in absolutely every domain. And even though you work together in the Ariel project, for example, you can draw on those resources, and and as you say, learn from absolutely everybody around you.
Yes.
That's what's so fascinating about this organization. I mean, I've been working for ESA for 21 years, and I still learn every day. Every day. And actually being in interviews is a fantastic way to learn about the life of a satellite project. Okay, so I think one of the interesting aspects of the Ariel team in terms of the timing is when it started. Because it's really a COVID baby, isn't it? Isn't it, Jean-Christophe?
It was a disaster. It was a major disaster. I started building up the team early 2020, really at the start of the COVID. So it was really the worst point in time where you can start a project. But it worked, actually. It worked very well. We managed to recruit the people we wanted with the right competence, the right skills, also from the human perspective. Building up the team spirit has been difficult indeed, because we are not on site, so we are seeing each other remotely most of the time. But on the other side, the few times where we are together at ESTEC, we are enjoying this time so much that actually we have built up the team pretty fast, thanks to those moments of happiness where to see each other again.
Yeah, absolutely. And that's just an observation from my side. There's all sorts of different jobs in the agency, of course, from procurement, like you said, to product assurance, etc., human resources, all sorts of different jobs, science positions. But there's something exceptionally unique about working in a project. That's been my observation, only in the sense that you're all working towards one common goal, towards a launch and beyond. So that creates a team spirit which is actually quite exceptional, if I have to say. Really, really exceptional.
Actually, if I may, in the army they say if you want to have a good team spirit, you must have a common enemy. And it's a bit this,
common enemy.
This is how it works. I remember. But here we have a common goal.
Yes.
And this is the beauty of it, is that everybody is working toward this common goal. We have a limited time, we have a limited funding, etc. But it's a common goal, and everybody is working towards that. And this is what Samra was saying. This is the best way actually to bring people together and come with a really constructive and positive spirit.
Yeah. But of course now, I mean, we're now May 2022. We're coming out of the COVID period, of course. So I guess you'll have an opportunity to, be in the office more and continue to create that team spirit.
We do.
Yeah. So can you just say a little bit about your education and what you did prior to joining ESA?
So I studied physics at university. I always wanted to work in the space industry, I have to say. So I was one of the kind of, wanted to be an astronaut at 6 years old type thing. But I was always fascinated really in space, and driven really by the kind of, sounds a bit cheesy maybe, but the desire to further our understanding basically of the universe. So after graduating, I was a young graduate trainee at ESA, so I kind of pretty much came straight into the ESA environment, and I was kind of hooked from the beginning, I have to say. My YGT, my young graduate trainee experience was very positive, because I realized that working in ESA, it's not just the scientific or technical aspect. There is also the kind of interaction with various different groups. There's the international environment, there's the travel, there's all these other things that makes it a really special environment. So after that, I worked in industry for a while. in Toulouse for about a year on a EGNOS, which was a navigation project, and then I joined ESOC at that time for one of the contractor companies. And then, after about 6 years in ESOC, I became staff. And so my path has been a bit, that's also one of the good things actually about working in the agency, is that there's quite a high level of mobility. So, I've gone from kind of working Earth observation to operations, so the Mission Operations Center in Darmstadt, to coming back to ESTEC and then working in the project environment. So they're all quite different jobs, but the common theme has always been that it's been a scientific mission.
Yeah. Okay.
Working with the payload. So yeah.
Okay. Gonzalo, I have a question for you about the stresses of working in an ESA project. What for you is the most stressful part of the job?
Well, there are a number of opportunities to get stressed. It's how you manage it. But of course, I think two aspects. One, our projects go through periodic cycle of reviews, internal reviews by independent experts of ESA that basically endorse that the project is going in the right direction. There are no major issues. So when we have reviews, it's always a moment to where you find out some issues that you have, and you have to handle them in a short period of time in the most efficient manner. So it's one of these stressful moments.
Can you maybe describe the biggest challenge that you've had in your role or your team so far in Ariel?
With my role, to be honest, the most stressful thing was the putting a team together during the COVID time. Being the first time I was putting a team together. So it was the dual challenge of having to put the team and the fact that we were all remote. And when you don't know the people, you have to sort of build trust in a different way. You have to make a sort of extra effort to communicate more because you are missing the face-to-face communication. There is a lot of passive knowledge you lose by not seeing the people every day, and this requires an extra effort. You have to plan a lot more to contact them to see how they are, exactly how they feel, because you don't see feelings or expressions when you do video conference. And this for me was stressful because I was used to and I like to work face to face. I really love it now that we're all back to ESTEC and we see each other. I like it much more.
Good. And maybe I have a question for Jean-Christophe. Can you describe a time when the team really had to pull together in order to collectively achieve a really important goal? And
Okay. Okay, I will say with Ariel, I think it was probably the first time where we really managed really to pull together. It was the negotiation with our prime contractor. It was, it's a contract in the order of 200 million, so it's quite a big one. It's always a delicate and a bit difficult negotiation. And you need to ensure consistency between all the various points that you are negotiating, all the various subsystems. And that's something where all the team actually went to Toulouse. So we're negotiating during part of the day. Other parts of the day, we're sitting all together in the meeting room, say, okay, what's your point, bum, 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 bum. And we're really trying to converge between us on those critical negotiations we wanted to have with the primary contractor. Actually, I like this event because it was really the first time almost in this. Again, we are in the COVID environment where everyone was spread all over, and it was really, we didn't have so that many opportunities to work together, and really liked this event. Even if it was challenging, but still we enjoyed it a lot.
And that was of course once you chose the contracting company.
Yes.
Can you maybe say a little bit about in ESA projects you have to write what's called an invitation to tender, okay? And you have to put it out for tender to various companies. So can you explain how long it took to create that document and how many people were involved in writing that document?
I do it?
Yeah.
No? Okay.
Well, maybe Gonzalo can take that.
Okay. It takes about, since the mission adoption review, which is the last stage of the preliminary phases, the ATT goes, the invitation to tender goes public 1 or 2 months after that, 2 or 2.5 months after that. But the preparation is much longer. It's 4 to 6 months in which you start between the finalization of the previous phases and the invitation to tender. The team that puts together the documentation, which is all the specifications, statement of work, all the documentation that is needed, is a slightly smaller version than the one that carries on in the project afterwards. So maybe 2/3 or a half of the project team. So I think maybe we're eight people more or less working hard on preparing the invitation to tender.
Okay.
And it's a long process. It's
Yeah.
between the start of the process and the time in which you sit down with the winner of the contract to negotiate is almost a year.
It's almost a year.
Yes.
Yeah, it's a huge time commitment. Oh, I just had a question. I've lost it. Oh my goodness, I've lost my question. It was a good one. Yes, I know. So in terms of the educational background of people in the team, without getting into details, but how many PhDs would you have? How many masters? Do you have an idea? Just in terms of, if people are interested in coming to work at ESA, what the kind of educational requirements that they would need?
I would say that's something you should know even much better than me, I guess, because you see everyone. But it's essentially a master that you must have as a minimum.
Oh no, but
to
I'm
work as
talking
an
about the
engineer.
Ariel,
But in
team.
the Ariel team, I would say everyone has a master, except one contractor that has a bachelor, and then PhDs. I don't know how many we have.
Maybe
At least
1 or
in
2,
One or
actually.
two.
One?
Yeah.
Yeah.
Yeah, one
Yeah.
PhD.
Yeah. But I think maybe that's an important point to add. If you do want to work at ESA, we have a minimum master's requirement for our professional positions. There are some positions that require a PhD, but they tend to be more related to the project scientists and things like that.
Yeah.
So for anybody who's interested in working at ESA, having a master's degree in engineering, actually, to be honest, it can be a master's in anything, but obviously if you're going to be working in a project team, then having a master's in engineering or science is the most relevant.
Yes.
Exactly, yeah.
Okay? So, can you, is there something, can you give a funny anecdote in terms of anything that happened within the Ariel team, in terms of relations with others, or anything within the team? Or maybe what's the most enjoyable part of your team?
I hope it's not for me. Is it for someone?
That's the one.
What can I
I think for us, since we were born in the COVID times, the fact that we've seen this evolution of, first of all, we had to negotiate the contract. The team was starting to be together more and more. Restrictions were being lifted, and the fact that at some point now we are sitting all in one area in ESTEC. It's a small area, but it's our area. It's our family, and the fact that we're all there together is really nice. I think we all feel very good to be together. It has not been straightforward for us.
Yeah. And what about working at ESA? Salma, what's your favorite part of about working at ESA?
At ESA.
Yeah.
I think it's the diversity in the work. As you said as well, you kind of learn every day. There's always new challenges, new issues. Each of the projects are different. So even if you've done a project before, especially in science, the next project you do will be completely different with different technology challenges, different teams. So yeah, it's the opportunity really to learn and interact with people with different expertise. And I think the environment, the general, as we said before, the fact that everybody's kind of working to the same goal. So in general, it creates a very positive spirit. There's never an issue with motivation in the team. So it's not even a factor, which I think is something very special compared to a lot of other industries and companies.
Yeah, I mean, absolutely. I mean, as I mentioned, I've been in ESA for 21 years, and one thing that struck me coming to this organization is the passion that people have. You know, people work, they work hard. People work hard. They have no problem working long hours if necessary in order to accomplish the goal. And that's what I find incredible. I don't think I've ever come across such passionate people in any kind of company I've worked in before. But also the international aspect of it.
Yeah.
What's your impression,
No, I was
Jean-Christophe?
exactly about to rebound on this one. Speaking about diversity, it's diversity on the people as well.
Yeah.
Because, I mean, here you hear plenty of languages when you walk through the various buildings. You have many nationalities. It's fantastic, actually. We also different experiences. People have been working in many countries before coming to ESTEC. There's a diversity also in the education, because people have been studying in the US, in Europe, and so on. Diversity of age as well. I mean, we have a lot of trainees. So you have youngsters in our team. The youngest one is 22, I think.
Yeah.
I'm the oldest one in the team. And you have, you have
Oldest and wisest.
Yeah, I'm sure you're right. I'm sure you're right. And then you have people that's up to 65 easily.
Yep. Okay, excellent. So as we mentioned at the beginning of the panel, we're going to open up the lines now to our viewers. Hopefully you've been asking some questions along the way. So we'd like now to see if there's any questions that you would like answered.
So actually there's a few questions that have come through. A lot of comments about how great this session is. People that actually had to sign off, but they're coming back for the video on demand. So it's a really interesting session. So I'm actually going to ask a first question, which was already kind of touched upon, which was, how was the teamwork impacted by working with so many different nationalities?
It's an excellent question. Who'd like to take that?
I think that's
Okay,
easy.
have a
We
go.
speak franglais, which
Franglais.
is we have our own language here, which looks like English, as you can hear. I think when you dive in the bath, you just enjoy it so much that it's easy actually to talk with the people and from different nationalities. I don't know how you feel.
Salma, did you?
Yeah, I think it's really, I mean, it's very unique. And it brings, I think it brings a lot of insight, not only because of the language, but also there's different mentalities generally as well. And different ways of approaching problems, which again kind of enriches, because the more options you have for like looking at problems, the more easy it is to find a solution. So yeah, I think it's
No, it's true. I mean, the cultural diversity within ESA, it's an amazing place to work, but it does pose challenges occasionally. Nothing that we're not, ready to conquer, of course. But, examples like there's some nationalities that have a different approach to timekeeping. But it's not always based on the nationality. Sometimes it's also based on the person as well. So, but there's the amount of expression that's used to communicate, to express yourself. So they're quite diverse across the different 22 member states. And in fact, here at ESTEC, at the establishment in the Netherlands, we not only have the 22 member states, but we also have a number of contractors that are working here from several other countries. But in a way, that's what makes it so dynamic, isn't it? Because we go to lunch or we go to the coffee corner, and we're constantly surrounded by different languages all the time. But we have one common language, which is Euro-English, which makes it a lot of fun.
And maybe if I can add something as well there, I think the people that apply to ESA and generally want to work in ESA, the fact that they are attracted by working abroad and being in an international environment already means that they're kind of disposed to be quite culturally
Open to
open
it,
and
exactly.
So it's quite
Okay, do we have another question from the
Yes,
audience?
we do. So this is a career question, and it's a person who's asking if they wanted to move from one sector to the space industry, what kind of advice could you give them?
From one sector to the space
so they're
industry.
outside the space industry and they want to get into the space industry.
Okay.
Apply.
Hmm?
Apply.
Yeah, exactly. Apply. Apply. I mean, we have to remember that at ESA, the predominant professions are engineers and scientists, but we have a whole series of others, what we call support services, which include communications, which include procurement, lawyers, IT support, human resources, etc. So we have a number of them. But if it's focused on engineering and science, then I agree with Salma, apply, because we hire people from very diverse backgrounds. We hire chemical engineers. We hire biomedical engineers for our human spaceflight programs. We even hire architects for, these structures in space. So, not too many, mind you, but but in our advanced concept team, we'll even hire architects. So yes, apply. Absolutely.
And so this is actually a pretty good follow-up question to that. It's another question that somebody asked, and is, what did you do before ESA to qualify to apply? So what did you guys do before ESA?
Well, you have to.
No, I think the question is, what did you do as a person, right? Like, what
Yes.
did?
Yeah.
Yeah.
I had my first experience was as young graduate trainee, which is it's a unique opportunity that you get to learn how the space sector works within the agency. But in my case, once I finished my young graduate trainee, I decided to go to industry, and I think that's the step there.
And what did you do in industry, Gonzalo?
I was control systems engineer, first in a company in Madrid called Sener, and then in Airbus in Friedrichshafen, when it was still Astrium. And I spent 5 years before coming back to ESA.
And what is your degree?
I did one in astrophysics and another one in aerospace engineering. So actually, I use more my aerospace engineering than my astrophysics.
So you've got a double master's, in fact.
Yes.
A double master's. Okay. And Jean-Christophe, prior to joining ESA?
I worked in the aeronautics industry in Toulouse first, so no space. Then I came to the Netherlands and I met my wife here, so I've been working for different companies in mechanical engineering, because this is also an easy way to go and work for ESA, is to be very competent in one field. I mean, the standard fields, mechanical, electrical engineering, software, etc. We need all those type of competencies. So basically, working through different support companies, I've been developed competencies in mechanical engineering, and then I joined. This is where I've been identified by the Rosetta Project, and they gave me a job as a mechanical engineer for Rosetta. After 8 years of thing, working.
And Rosetta was the mission that landed on the P-67 comet in 2014, correct?
Yasimenko.
You see?
This is the name.
I wasn't even going to try to pronounce it. But indeed, that's another exciting mission. I mean,
yes.
it's Rosetta was one of our most publicized, fantastic missions, launching in 2004. And then, the Philae lander didn't had a bit of a rough start, didn't it? But eventually landed on the planet in 2014. So that was fabulous mission. Any other questions from the audience?
Yeah, so we have something that's a bit more specific, and it was a question asking, how can someone who did a PhD in astrophysics adapt themselves to a project related to the Ariel or Plateau kind of projects?
Okay, who'd like to take that one?
Someone with a PhD to
Astrophysics.
So somebody with a PhD from astrophysics, how can they adapt to working in a project environment?
Well, I think many of the people in the scientific consortium that work with Salma have a PhD, and they have knowledge in applied physics, or a lot of knowledge in detectors. And these people have, of course, a natural space in a project. It's a natural transition. And of course, a PhD also gives you a lot of capability to solve problems.
Yeah.
So it's not exactly what you need to know, but also
Yeah.
your capability to solve issues, which I think is perfect for a
Yeah,
project.
absolutely.
And if I can maybe just add on to that, if I, having supported different groups in ESA, one of the things, one of the characteristics that I would describe as people who are working in a project as opposed to perhaps on the scientific side is, of course, it always has to be within budget, within schedule, and within the requirements. And there's a tendency of the scientists to want the best performance, etc. But the role of the project manager, so Jean-Christophe's role is to launch in 2029 within budget and on time.
Easy requirement, you see.
And that's not always compatible with the wishes always of the scientific community, because they want more and more and more. So this is the challenge, of course, and I guess Salma, that's your main challenge in your role.
Absolutely.
Is you're dealing with the scientific consortiums who
Yeah.
want more and more and more.
Yeah.
And then you get pushback from Jean-Christophe that says no, no, no.
We have to deliver on time. Absolutely. Yeah.
Good. I think do we have time for a couple of more questions?
Well, we have a pretty good one that came in. How is the collaboration of the Ariel project team with the other ESA departments, for example, procurement?
That's an excellent question. Who'd like to take that
Yes,
one?
that one is for Jean-Christophe.
Okay, take it. So it's true that there's the project, which is a rather small family. Okay, but to develop a satellite, that's not something we can do on our own, even with our contractors. So we need the support from other people, and the other people. So we have the technical directorate that gives the technical expertise that was mentioned a bit before, and we have also the expertise from the contracts, and also from the industrial policy, which tells us, they tell us as well how we can place the contracts, including below the Airbus, which is our main contract. Below, there are subcontracts. We are giving job actually to many companies in Europe. Companies that are big ones, small ones, in different countries. And this spread of contracts through Europe is also driven by the requirements that we get from the industrial policy. So we're working actually quite closely with them, and we inform them about the progress of the way we build up our industrial consortium by selecting all those companies all over Europe to make sure it fits within the ESA policy for the industrial capability in Europe.
And for the most part, the contracts officers either have a legal background or a business background. Some have a business background.
Some other, I think, our contract office, the previous contract officer we had done political science. But I think that our contract officer has a legal one. Yeah.
Yeah.
But that's there are different possibilities.
Yeah, different possibilities indeed. Okay, so I think we have to conclude. So I want to thank all of you very much for your precious comments and your expertise that you shared with everybody today. I also want to thank the viewers. So basically, if you're interested in applying at the European Space Agency, then we encourage you to visit our website, www.esa.int, and click on careers, and you'll be able to see all the available opportunities there. So I hope you enjoyed the session.